I give a lot of advice about how to start studying for the GAMSAT, but today I'm going to go one better and show you the exact process that I would do if it was my first time sitting the exam and if I didn't have a non-science background. Hey there, if you're new here, my name's James. I'm a second year medical student and GAMSAT tutor, having scored 77 in Section 3 a few years ago. I made this channel to share all my tips with getting into medical school, so if that sounds interesting to you, make sure you subscribe to the channel so you don't miss any of my future videos. As I mentioned in the intro, what I'm going to do is show you the exact process that I would go through if I was sitting the exam for the first time and came from a non-science background. So these clips were taken from a Q&A event that I ran for my community, and basically I pretended as if I had no science knowledge and that I'd never seen these questions before. And what I tried to do was just show you how you can actually utilize the information that's there and the questions that I would ask myself to start seeing how that information relates to each other. And really, what I want the emphasis to be is how you can actually work through a problem, ask yourself questions about what might need to be used, and how you can use that to actually identify skill and knowledge gaps that you will need to solve problems on the actual exam.
Yeah, I guess what I try to get across a lot of the time is how you can improve your own study, because it's kind of well and good to teach you things but end of the day, I think it's not really a knowledge-based exam. You've probably heard me harp on about that for a long time. It's about developing those problem-solving skills, and I think really the only way to do that is through engaging a lot in the questions. So a lot of the stuff that I focus on, although there is, undoubtedly some content and knowledge that you need to know, a lot of it is kind of how you study as well. So in today's one, I'm doing something a little bit different. I was hoping someone could give me any kind of ACER question. I've got them all here. And I think just more think about some ways that we can break that question down in terms of figuring out what we need to learn. All right. Cool. Looks difficult. Now, I think a lot of people think that, like I've had this comment before that, oh, you did a science degree, so you must know all this different stuff. But I think that although it helps you kind of learn a lot of the words, it doesn't really serve that much of a purpose. And I think that how I like to think of it is like if we can get a whole big list of steps, I suppose. So if I was approaching this question, I would think, so as usual, I always start at the question, right? So I'm approaching this like I don't really know anything about the question. And I'm thinking, okay, I need concentration of oxalate ion to form the kidney stones. I've kind of highlighted everything there. So I guess automatically everyone should be able to go through and pick out the key things in the question. So I would always start like that. And then I'll just start thinking, how could I get that? What do I have? What information do I have? What information could I get? Is there some theory? Is there something else? And we can kind of just go through and just gradually build on that. So does anyone see any information that we have that we could use, maybe?
pH.
Okay. pH. So you mean this pH? I like it because I guess what we're trying to do, if I'm matching that up, we've got kidney stones in typical kidney fluid. So that could be relevant there. What could we have that matches up to oxalate ion?
The concentration of calcium ions is 1.5.
Yep. Okay. But that's calcium. How does that relate to oxalate?
I thought because it was calcium oxalate, the Ca.
Yeah, so that's kind of what I'm getting. Yeah, exactly. So
Yeah.
that there should be some link between this and that, and then we can start to just keep fleshing that out. So we've got calcium ions, then we can start you don't really need much science knowledge to be like, well, this calcium ion has to be this thing here. So they've also told us calcium oxalate is that thing. So we need a little bit of science knowledge, I guess, to know that this thing here is the same as that. But I guess that's something, if you were studying, you would think, okay, is this the same as that? Is this the same thing as that? And this is something that you can start thinking, all right, well, this is something, let's say you didn't know this. You'd say, all right, well, maybe I need to know how to represent a chemical formula as a like structural drawing or something like that. All right, so you jot that down and then you start seeing if there are similar things in the other questions. So I really think it's less about looking at each question in isolation and seeing if you can find similar things. So if we just have a quick flick through, so we want to see, this is something that we've identified here, that we need to draw this link between the written formula here and that structural drawing. So if I just have a look through other questions in this booklet. Okay, so I know a little bit about this question, but in this one, we need to count the number of stereocenters. Okay, so if we look at the answer options here, all of these are about stereocenters. Okay, now the best way to calculate stereocenters is by what a stereocenter is. Now, don't worry too much about this because, we don't want to try to cover the whole, necessary scope of knowledge. But the best way, in my opinion, to find a stereocenter is to draw it out as a structure, because a stereocenter has 4 unique groups. I can't write, apparently. 4 unique groups. So if we look at this carbon, it's got 1, 2, 3, 4. All of these groups are different to each other. So that's a stereocenter. Now that's very easy to determine if it's a structure. But these, you'll notice they've given us these kind of worded formulas for these molecules. So why do you think they're giving us these worded things? If I drew this out, it'd be very, very easy to determine the stereocenter. So we've just automatically gone, okay, we've got a question here. Where was it? 2. Gone past it now. 3 pages before that, we've identified something we might need to know, and then we've seen it again. So we can already start to put that as a skill that we need, and then we can start to build it into those frameworks that we have. So maybe this is a stereochemistry framework or a stereocenter framework, and this is one of the skills that you'll need to do in that particular question type. Does that kind of make sense how I'm thinking about it? So it's step by step, but then also looking at the wider scope of things to see how that skill is going to fit in multiple different, places. So we've now identified that. If we couldn't do that, we've now identified it as something that we need to get better at, and now we know how to do it. So there's heaps of resources to find this stuff out. So Khan Academy, number 1, probably some GAMSAT specific ones if you really want to, but really it's quite, it should be quite easy to find that, especially when you have it as a really targeted piece of information like that. So we've now done that, tick that off, and now we can we know that this thing represents that thing. So do you think we could also draw the assumption now that, is anything standing out at people now that maybe wasn't, in terms of how we're going to solve the problem, what is an oxalate ion? Has anyone heard of one of those before? I certainly haven't. So, but just based on what we've done so far, just finding stuff that we think is relevant, can anyone hazard a guess to what that oxalate ion probably is?
Is it the one, the negative OOC/CO
Yeah.
negative?
Seems right to me, So if there are any things that you don't know about that, ion just means a charged molecule. So if that's something that you identify that would help you determine that, perfect. So you can still find more and more stuff. But I'm sure, you know, if you've linked this to that, you've found a concentration of calcium ions here, surely you can start to determine that that's the oxalate ion. And already we're kind of like moving through this question quite well, without much science knowledge in particular. So let's keep going with that. So we've now got, I'll just kind of highlight as we go. So where are we going to go next? What are some things that we could try? Any ideas?
Am I wrong for thinking that the oxalate is the last structure in those diagrams?
This one
C-
here?
Yeah, that one.
You're absolutely right. And again, that is the same skill as what we had before. It's can we kind of go from a worded structure into a structural drawing? So that's another thing. Basically, a lot of this question is about, can you represent a molecule in several different ways? We've gone from, I don't know the exact name for these, but this is kind of like a formulaic representation. This is semi-structural, and then I think that's structural or something like that. So basically, I would just, through this question, I'd be thinking, okay, these are 3 skills that, you know, I really need to know inside and out. All right, so we've now found that. Where might we need to go now? And if you don't know anything about science, that's absolutely fine. I just want, even asking questions like, okay, what other information do we have? Is there a way to link this to that? So, you know, the way we've been going, we kind of found the calcium ions, right? We found this. That helped us find this. We're now here. My brain would kind of be thinking, well, what if I found that? What if I found the hydrogen? You know, just as like, I'll ask myself a question. So is there any way that I can get the hydrogen? Maybe you'd think, okay, well, you know, we highlighted this piece of green information before. Is there a way to connect pH to H? Because I would probably have in my head somewhere, you know, acidity is linked to pH. Acidity is also linked to hydrogen in some way. Maybe I could link the two. And then, yeah, there is a way. You can go from pH equals the negative log of H. So here we've identified more and more skills. So I might see, I'll have a quick flick through because this one's a little bit more niche. So yeah, here we go. In the one that we're doing, we're going to need to do some kind of log calculation, I think, to get the hydrogen ions. And this question is kind of the same thing. So you've got pHs, you're going to have to solve logs. So we've kind of identified another skill that's required for this question, and that's solving logs, you know? So I kind of think if you can find it in 2 questions, you should really focus in on that skill. So, and it gives you a bit more context as well, because it's all well and good just going and Googling, you know, how do I do a logarithm? But it's far better if you actually see why you need to learn the logarithms and then learn something about them and then see if it helps you for the problem. I think it makes it so much more real and tangible, and it really helps kind of solidify the concept in your head. So, what am I doing here? We might not even have needed to do that, actually, now that I'm thinking about it. So how about actually, let's just keep going down that path. So maybe we're thinking, okay, how does that help us? Does it help us? And maybe this is where we kind of end up at a bit of a dead end. Like it was flowing quite nicely, but now I don't really know where to go. Like if I calculate this pH, so got 8.2 equals negative log of H. So obviously you need to know how to do these, but that would mean the H equals 10 to the negative 8.2. So I just think, how does that help me? Does it really help me? No, because it kind of just tells me how much hydrogen I have, but I need to know how much of this I have. So it doesn't, I don't know. And then I've kind of got all these other, you know, H's. So maybe I'm thinking, no, this isn't the way to go. So that's kind of example of how you might try something, which I just did. I actually thought that was going to be how we'd get the answer. But then it doesn't seem as relevant now. I don't know if anyone kind of thinks that. I don't really have anywhere else to go with that hydrogen thing. So then, is there anything else that stands out? Is there any other way that we could start to link, start to link these ideas to get the oxalate ions?
Is it something to do with the solubility constants?
I like the look of that. Yeah. So maybe is there a way that we can link that formula? Because if we had, so we've got this, don't we? So we should have, I'm kind of thinking maybe we need like the same amount of this. If we had the same amount of that, maybe that would help form that, because it's saying that's the thing in kidney stones, right? This first thing. I've got too many colors. I don't have enough colors going on actually. So I'll highlight that one. So,
But would the formation of kidney stones, it would be precipitation rather than like the solubility, like it's forming something. Is that right?
maybe. What? So in terms of what? So how about? Yeah. So what do you? So that wouldn't help us, or
I don't know.
that's all right. That's all right. So you can ask those questions, and then you can ask Google, because I kind of think that this is like we're pretending as if we've never seen anything like this before, So maybe you're like, how do I, can I get a solid thing from the solubility? I don't actually know. And to be honest, I don't think that, I think generally a really deep scientific answer or explanation for things like that, probably not the case. There's probably like a simpler answer. I don't know if you found that, Taylor, in your things, but there's like it's not. I don't know. A lot of the time, it's not like a deep scientific answer. The information should be there for you. I don't know if you agree with that or not.
Yeah.
Yeah, a bit of hesitancy. Maybe not. Anyway, well, what if we just did? So, I've had to look this up because I've forgotten the exact formula, but this is stuff that you can look up yourself when you're studying. So KSP, this formula, is just equal to concentration of A times concentration of B. What if we just gave that a go, right? So we have 1.5 millimoles here. So what do you think? Is there an issue here that I'm circling? Millimoles and moles. So this kind of goes back into, one of the things that I really take a bit of pride in, and that's unit conversion and noticing that units are different. So 1.5 millimoles, maybe you start thinking, oh, how do I convert units? And maybe you divide it by 1,000 or something like that. I don't know, but just giving you ideas about things that you might, pick up as you're studying. Should we convert? Yeah, I think so. So this is how I convert units. And this is going to equal 1.5 times 10 to the negative 3 moles. So that's, maybe you're like, oh, a little trap that might be there is that the units are different.
If you're enjoying this video so far, I'd really appreciate it if you could like the video and leave a comment down below, as it helps me grow the channel.
So let's just plug these in. So the solubility product, so if we do, so it's A times B. So let's just say that this is B. So this is getting really messy now. We'll say that this one here is B. This one is A. Then this number should be A times B. And we've just worked out the concentration of A is that. So 3 times 10 to the negative 9 equals 1.5 times 10 to the negative 3 times B. All right, so if we rearrange, so here's another skill that I've identified, rearranging equations. So am I able to rearrange this for a variable? That's another skill, and you can write that down. So B equals 3 times 10 to the negative 9 over 1.5 times 10 to the negative 3. Can I solve this? What skill do I need for this? Index laws, right? So these are things that you can just keep finding. 3 divided by 1.5 is 2. And then negative 9 minus 3, so it's plus 3 is negative 6. So I think that's D. So I'm not 100% confident in this answer. Let's have a look. 46. So when I'm thinking about, when I reflect on this now, because it's just kind of like, I didn't really know. Like, I kind of went hunting down this pH route because I thought that would give me the hydrogen, which I could use to get this, which I could get this, which I could get that. Didn't quite work out. I didn't quite see an avenue to get there. So that's why I started looking at this KSP. So, and then and I didn't actually know what the KSP equation was. So I've forgotten it, but it is just multiplying the two things together. So, things to take away from this is that this is a formula that I need to know because they've just given me this, big problem and they haven't told me that equation. So if they haven't told me that, they're expecting me to know that so I can apply it in the future. And then when I look back at the KSP, this is basically, because I think that really we want to have a simple understanding of a concept so that we can apply it. So what this thing is a way to express the equilibrium constant for a salt. So it's basically the point which a salt dissolves, right? So that means at some amount above or below that, I don't know which way it would be. I think above that, if we think about that equation, as we increase that, if that has to stay the same because it's a constant. If we increase that thing, then we should actually start to see the salt not dissolve anymore because it's kind of reached its limit or something like that. So you can start to form these like really basic assumptions about it because there's, I think it was Taylor was saying, can you link solubility to, what was the word you used? Was that sciencey one?
Yeah.
Precipitation, that's the one. So you can tell how long it's been since I've been in a, biochemistry lab, but apparently you can, and it kind of does make sense. You can make sense of it in your head, and then you have this simple concept going forward, and then maybe I think I don't have that many questions that immediately come to mind about KSP, but maybe you can go to another question and find KSP again, and then you can compare and contrast them. And that's when you can start developing like a really in-depth understanding about how it might be assessed. All right, so we got there in the end. And I guess through that process, we've identified a bunch of steps along the way that we would need to know. So we know that we need to be able to link kind of a written form of a compound into a drawing. We need, and potentially from that into another structure or something like that. And that's I can think of heaps of questions where you need to be able to do that. And then you need to be able to link that to KSP. As a part of that, you need to be able to do some unit conversion, then need to do some index laws, So we've kind of identified a bunch of different skills. And then I would just say, what value is there putting this in as like a chemistry question? Is it really that chemistry based? Like the chemistry stuff we did was probably the easiest stuff. That's kind of how I would go through and just really, especially as I'm starting, just step by step and just ask myself, can I do this? Can I do that? Can I link this to that? And then you start seeing how the information falls into place.
So I've alluded to this a few times in the video, but now that we've actually solved the problem, we want to go and find similar problems to the one we've just done and compare and contrast them to form what I call a problem-solving framework. If this is unfamiliar to you, I think it's a really important concept, so I'll leave a link to a video here about how and why I think you should form frameworks when you're studying for the GAMSAT.
This is probably a good example of it. So let's say you get really, really stuck. And I actually say to people when they're starting out, put no time limit on it. Just sit with a question for 30 minutes and like leave, come back, whatever. Just keep like trying things out, Googling things, you know, asking yourself questions. Can I link this to that? Kind of what I was doing with the hydrogen. Can I link this to that? Can I do this? What does this mean? You know, finding things. And then when you really feel like you've exhausted absolutely everything, find the answer. So we know the answer is D, right? How would you get that? How would you get that answer? So maybe you think, okay, well, I see a 3 and I see a 1.5. If I could somehow divide 3 by 1.5, maybe then I would get 2 because that's what that would equal. Or maybe I could divide 6 by 3 and that would give me 2. So is there a way that I can put this number in a numerator and this number in a denominator, or this number in a numerator and this number in the denominator? And then you can start to look at ways that you might be able to do that. Don't give up. I think a lot of people give up in like 1 or 2 minutes, and they feel like they've tried everything. And I actually find when I'm tutoring people that I think it's really interesting. I just ask them questions, and maybe it'll take 10 minutes of me asking questions and sitting with it for a little bit, and they think, and I ask them another question, but eventually they'll get the answer. So what knowledge are they missing there other than the questions that I'm asking them? So if they could ask themselves those questions, then they should be able to get the answer as well. So I do think that the level of knowledge you need is not exceptionally high in science. I'm not saying you need nothing, but I don't think it's out of the scope of anyone. I think anyone can learn the necessary knowledge for the exam, but it's about kind of finding ways to ask yourself creative ways that you can apply those concepts to solve problems.